Hello, good morning to all, and thank you for the opportunity to present an important case study for our company, and that has allowed us to take conclusions that reflected in new product developments. I'm talking in the context of structural glass and minimalist sliding doors and windows. And the case study is for a house that was built in 2015. Next. The premise was a window we were invited to develop that had a 8.3 meter height and with panels of 8.3 meter by 3.1 meters. I will go briefly through the history and the challenges that the design of this system has brought to us. And I will also try to demonstrate that the path we followed that eventually led us to a product development that we were not expecting to have. Next. Minimalist doors and windows are relatively recent as a product category. So we can trace back its origins to the international movement and to 1920s architecture from last century. But what we are talking of today is mostly a 20-year-old technology that has expanded very rapidly since 2005. Its main feature is the utilization of structural glass as the main structural component of the window, this allowing to minimize all other components in the system. It is quickly becoming a mature technology, and it is also becoming increasingly more and more utilized in most residential and commercial projects. Next. We started engineering tall windows or very large windows back in 2008. And back then, most tests were empirical, and we tended to do these windows quite narrow, so limiting their width to 1.5 meter. Our experience with the really jumbo panes, or with the 6 by 3.2 meter glass panes, started in 2011. We started doing projects in India, where the climate also allowed us to be more experimental. And we started facing here, we started understanding what would be the industry limitations that would make these projects difficult to accomplish. So back then, it was still difficult for example, to understand or to know which glass producers could tamper with good quality glasses of this size. We did the first project in 2011 with 6 meter windows, then we did a second project in 2012 with 7.2 meters. Both glasses were sourced in China. The first project was done with a temporary laminated, a single sheet of glass. The second one was already with the IGU, a double glass unit. And these projects allowed to take valuable lessons that we used in the following years. Next. Back then we were always employing, or most of the times employing, a system that allowed us to use 38 millimeter IGUs. We were not so much concerned about the thermal performance of the system. We were not so much concerned about the comfort aspect of the system, but more concerned about the mechanical strength and mechanical properties of these systems. We were also, so depending on the markets where we were operating, we knew that we could use this system as a triple glass system with smaller units, but we had no need or no requirement to change the system we were typically using when doing these larger projects. And when we started seeing that the scale in the windows was increasing, not only in India but globally everywhere, then we started understanding that we should start developing systems that were specific for large panes of glass, and that also allowed us to improve performance of the system. So 2014, we finally finished a new system, a product development that allowed to do large size triple pane glasses, up to 54 millimeter. This is the first project that was done with triple glasses of large dimensions. It's a project done in Switzerland. And with 54 millimeter IGUs, it was basically a very simple scale of the previous system that we used in India with 38 millimeter IGUs. Next. And we did jumbo-sized triple glass sliding windows for the first time, also in Switzerland, in a project that is has almost no walls, where all walls are also windows. This project showed us what would be, again, the limits of the system, given we had panes weighing more or less 1 ton. And this was another limitation of these systems for very large windows. So we hit another constraint that will need to be re-engineered for future projects. The same year, or the following year, 2015, beginning of 2015, we were invited to develop a system for a project of Pringle Research Sharrett Architects, a project in the UK that had these 8.3 meter by 3.1 meter sliding windows. It's a house outside of London, not too far, in a very beautiful area, a natural reserve. The house is organized in simple ways. It's organized around two courtyards, and these two courtyards have these two very large, identical openings with 4 panes of glass each that open from the center to the sides. And we decided to take on this challenge based on our previous experience, though we did not anticipate some of the complexities that would arise from this project. Next. The project was, from a sustainability point of view, it was the client and the architect, they were very concerned about the implementation that would be done. So here in this project, we were really requested to have a high-performance system with great thermal efficiency, with very good air and water permeability and drainage solutions. So we had really to upgrade what we have done previously. And we started actually by developing the system from the mechanical strength point of view. So we started sourcing and we started talking with suppliers for most materials, but we had also the concern of guaranteeing that with these extreme sizes, the system will perform even under the most extreme circumstances. And we are talking about the region of the UK where you are allowed to engineer the projects for higher wind loads than in many other territories, and especially the territories where we have been doing these projects before. So we ended up specifying, or we ended up designing a system that had a 70 millimeter IGU with a 90 millimeter tempered glass on the outside face and a 24 millimeter tempered laminated glass on the inside. This system meant that each panel weighted more or less 3 tons. So we were talking about a very different type of product where each panel was 3 times heavier than the projects we did before. And this brought a different set of complications and complexity that we had to solve. Component by component, we started re-engineering the entire system to the point that at the end, we had no single component that we could use from our previous systems. The bottom track was different. We had to change the type of bearings, the materials, the reinforcements, the sizes, the way we calibrated the window, the way we drained the water. Everything became different. From this moment on, we really went completely apart from what we had done before, and we started thinking about a new system from scratch. Everything had to be different, even the motorization, because things as simple as connecting a window to a belt and to a motor no longer worked under these extreme dimensions. So we built a mock-up. We built a mock-up exactly the same size in steel, not with the glass we would use, because the glass was so complicated to source. The glass for this project ended taking 5 months to be delivered, but initially our best expectation were around 9 months to get these glasses delivered from China. It was campaign glass, low iron, low E-coated, very complicated glass. So we built a mock-up in steel, and next slide, please. And these that you see in the picture, and this mock-up allowed us to test the movement, the friction, test the motorizations. We did 15,000 cycles, opening cycles with the window. We did all sorts of testing we could imagine to limit the risks that projects like this involve. Next one. Once we passed this phase of product development, where we tested what we believed by then to be everything we could test to limit the risks of implementing a solution like this, we started doing the installation. The installation was on itself as challenging as the product development. So installation meant that we had to check everything from delivering the glass to site, where you can imagine a glass this size, it does not travel easily in most roads. And this has obliged us even to reinforce a bridge, for example, to access the site, make vacuum suckers that were adapted to a glass of this dimension. And the installation was very complicated to plan, obliged to adapt and to make new tools, to train a team especially for this. We had a team training with the vacuum company, for example, training with models until they could manipulate a glass with extreme precision. So glasses like these the precision to install a glass like this is 8 millimeters, so it's extremely difficult to do. So we did extensive training before doing the installation, and finally we started doing the project, and more or less according to expected, we managed to install everything. At some point, we did we started testing on site the real window, so installing motorization, making cycles on the window, testing with water, testing, and we started verifying that the product was working well. So despite all complexities that were not unexpected at the beginning, things started working well, and we were really happy with what we were learning from this process. And the result at the end is what you are seeing in the picture. So the windows were installed. We are talking about windows that have, like I said, 3 tones each panel, but that were working smoothly, where people could open and close them and have a very spectacular view to a very unique landscape in a way that has not been done before. And with this, you can change slide. And the final result is this. So the house right now is completed. The windows are working very well. We had a problem that was, I think, impossible to account for in the beginning. So we did a HST test for the glass, and we thought that given the procurement was so long, the lead time for delivery was so long, and 8 of the glasses were similar, we decided to fabricate 9 glasses, 1 spare. And this spare glass we kept in our factory. And actually one of the glasses, after 2 or 3 months of being installed, has exploded. Not because of nickel sulfide inclusion, but still it has exploded, and then we had to reinstall one of the panes. This is the only problem we have faced in the project, but still, you can imagine how complicated it is to replace a glass this size, to source it again, to reinstall it again. We had to do this one time. We have also installed in this house a glass in the same proportion but horizontal over a swimming pool. The same product had to be slightly modified, so instead of being an aluminum window, it was a stainless steel window. Full stainless steel with composite bearings. The window slides on the top of the swimming pool. The lower track is rebatable, rebates inside the swimming pool, and it allows to create 2 areas, one exterior and one interior. So we can say that at the end of this process, we have understood in a different way we have understood before what were the really critical aspects to take into account when developing a high-performance product for large size windows. Above a certain dimension, above a certain type of configuration, windows become like walls. It's actually difficult to distinguish the characteristics that ones and the others need to have. We test the materials and the solutions to their very limit, and this obliges to revise procedures, obliges to do extensive testing, and it's not possible to do everything well on the first attempt. We need to do and redo and be patient with this process, but the outcome proves to be very worthwhile. Next. Among the issues that we better understood, I will highlight 3. The most basic aspect of a sliding window is how it is installed and how well the base is built and how stiff it is, how level it is. And this characteristic, it only gets more and more important with size. The bigger the window, the more important this aspect becomes. It's a very basic aspect of any window. In this case, it proved to be one of the most important and one that cannot be adapted after the windows have been installed. This needs to be taken into account from the beginning. A second aspect is the performance to air and to water. With size, we tend to increase tolerances in the system, and this drives down window performance unless some measurements are taken from the very beginning, and this required us to change the design of mullions and of the drainage systems extensively. And this process was extremely valuable because we could translate these improvements into our standard and legacy systems as well. So these improvements we have done on a large scale could be reverted to a smaller scale and make all systems much more efficient. And a final but central aspect is that with the new series that we designed based on the experience for this project, we designed a system with 60mm glass that is a high-performance system for triple glass and large-size windows. We improved so much our systems that we actually managed to develop a system for large glasses that is Minergie-P, so it's suitable for Passivhaus. It is a state-of-the-art system that allows us now to deliver a good solution for customers and architects a little bit all over the world. In every climate, and this is a valuable lesson from a project that was not intended to be for this type of product, but that allow us to revert this or to take this information into account into a new product development. Thank you very much.
Thank you very much, Pedro, for this very interesting presentation. Maybe there is some time for questions. Yes, we have here a lady.
Thank you. Very interesting. I'd like to know what say you meet in Passivhaus, your values. I'm just wondering for the weather performances, what kind of tests, pressures, what's the maximum test pressures it was tested to?
So for the test in the UK, for the project in the UK, we tested to the project specificity. That was the wind load was 1044 Pascal. Okay. But for the new product development of 60mm, we have in the meantime used the system to certify it for a hurricane, for example in Florida. So it is hurricane rated, is velocity for the high velocity zone, wind zone 4. That means that it is tested to 2400 Pascal, I think.
And the second question is regarding its operation. So these doors are generally motorized. In the event of a power failure, for example, what is the default setting, or how does it then get operated?
They are typically installed with batteries. So you have these batteries allow you to have 10 cycles, and we usually program the windows to be they are fail-safe, so if the electricity fails and you use the power in the batteries, then you can open them manually if you need. More recently, we have a product development that works in a different way, where we can override the motor and open it manually with a magnetic gear that allows to disengage the motor. But this is a very recent development. In the project I've shown, the motor is connected to a chain belt. It has batteries that allow the windows to have 10 cycles after electricity fails.
Okay, more questions? Yeah, here in the front.
What kind of deflection do you have? The center of glass deflection or side deflection?
In the project in the UK, we had height over 220, 36mm deflection.
36, thank you.
More questions? I have one further question. I know your standard system, the panorama the sliding doors are bonded. The insulating glass is bonded to the frame.
Yes.
I did not see any bond line, any glue line here with the large system. Were they also bonded?
The bonding is an aspect of fabrication that is, we have a U channel, aluminum or a stainless steel U channel that protects the glass all around. And this bonding, this is the component that is bonded. It allows to rectify the geometry of the glass. It makes the movement better. Is a very important aspect that distinguishes the large sliding window systems from the smaller ones where you can use gaskets and where the glass is not bonded to the profile.
Mm-hmm. Okay, thank you very much. Okay, thank you very much.
Thank you.
Once again, Pedro.
Hi there, did you like what you just saw? If you did, why not like the video? Drop us a comment below, as well as share the video with others, since GPD is all about sharing. And to receive more videos in future, subscribe and don't forget to click the bell icon for notifications. Ciao!